Dead easy. Firstly, simplifying, quite often the first question on the paper. Root 80, for example. What you're looking for is that biggest square number that goes into 80. So in this case, 16. What's left is 5 as a factor. So we've got root 16 times root 5. Simplifies down to 4 root 5, because the square root of 16 is 4. Boom. Done. Easy. 1A, out of the way. Second type. Could be question 2, could be question 3. Expanding a double bracket. Claw method. Dead easy. 2 times 4 gives us our 8. 2 times minus 3 root 3 gives us 6 root 3. Take away 6 root 3. Root 3 times 4, 4 root 3. And lastly, the hardest one, root 3 times 3 root 3. Got to be careful here. Root 3 times root 3 is 3. And then multiplied by the second 3 in front gives us our minus 9, because only one of them is negative. Then simplify down, 8 take away 9, minus 1, minus 6 root 3, 4 root 3 gives us our minus 2 root 3. Boom, question 2 done. Right, rationalising surds, again, early on in your exam, could be a part of a bigger question. Easy. Just one term on the bottom, so therefore we're looking for that surd, root 2 in this case, multiply top and bottom, because that doesn't change the fraction, by that root 2. Be careful. 3 root 2 on top. Here, root 2 times root 2 gives you that 2, times by the 4 makes that 8. Dead easy. More difficult, more complicated, is when you've got 2 terms on the bottom. So I've picked one here, particularly awkward. Root 2 minus 1 on top, 3 plus root 3 on the denominator. Now, look at the denominator. So what we multiply by, 3 take away root 3. It's just that change of sign, isn't it? Top and bottom multiply by the same thing. Doesn't change the fraction. Then carefully, just like we did before, that claw method. Top expands to 3 root 2 minus root 6. Root 2 times root 3, root 6. Then you've got take away 3 plus root 3. Because all 4 terms contain either a different surd or not a surd at all, they've got to stay separate. On the bottom, nice and easy, we've got the difference of 2 squares. So 3 squared take away root 3 squared. So 9 take away 3 leaves you with 6. Then just carefully simplify term by term. 3 root 2 over 6, so a half root 2. Root 6 over 6, so a sixth root 6. 3 over 6 just leaves you with a half, and then you've got root 3 over 6. So therefore I've written it as a sixth root 3. Awkward, you do get them, you've just got to be careful. Think about your work with your surds. Think about carefully expanding. Dead easy in an exam. Nice marks.
Okay, so this is a basic indices question, and they come early on in the paper. And the key thing to remember, if you've got a fraction under C here, the bottom bit's the root and the top bit's the power. So here we've got the square root and then power 1. So square root of 81 is just 9, and that's nice and easy. Okay, there's the power there. So this one we've got power 3/4. So the 4 is the 4th root, and then we've got to do the power 3. So we're going to cube it afterwards. And the 4th root of 81, it's never going to be anything ridiculous, it'll be a small number. And if you think about what number to the power 4 so we can get 81, go through your real numbers and 3 is going to work out nicely there. So we've got 3 and we've got to cube it, so we get 27 as our answer. Okay. The next bit, we've got the same thing, 81 to the power 3/4, but we've got a minus involved. And the minus means you've got to reciprocate the number. It means flip it upside down. Or if it's a fraction, just invert it, reciprocate it. Okay, so we've got 1 over 81 to the 3/4. That's what the minus has done, it's put 1 over. So if we use our previous answer, that 8 3/4 is 27, we've got 1 over 27. Okay, in this question we've got slightly more difficult, because we've got a bit of algebra involved as well. I mean, the first question is fair enough. Got to do the 4th root for that 4 there, and to the power 1. So the 4th root of 16, nicely number 2, easy. So let's look at the second bit. We've got all this stuff to the power 3/4. Well, let's do the 16 first. Okay. So the fourth root of 16 we worked out earlier was 2, then we've got to cube it because that 3 is the power. So 2 cubed, that gives me 8. So I've done that 16. Now x to the power 12, all to the power 3/4. What we do, we multiply the powers. 12 times 3/4, or 3/4 of 12, is 9. Okay, so there we've got that x to the power 9 there.
Okay, here we've got two questions that on the face of it look very similar, both completing the square. Each one has a little twist in its own way. Let's have a look at this. The basics are the same in each case. When I complete the square, I'm going to make my bracket, and I'm going to take a half of b and put it in my bracket. So I get from the -4, I get -2, all of that squared, x minus 2. And then I've got to take away whatever's here. I'm taking that away there, squared. And then I'm adding the 9 that we've got from the question. Alright, and all that simplifies down. That's going to be -4 plus the 9 gives me the +5. So my final answer is x minus 2 all squared plus 5. And then question asked in the form minus p plus q at the end. So p in this case is obviously 2 because it's -2 minus p, and q is 5 because it's plus q plus 5. Alright, then part C of this says write down the minimum value of this function and the value of x for which it occurs. Well, all it means when it's talking about that is when does this bracket equal 0? So if this bracket equals 0, the function equals 5, and the value of x that makes this bracket 0 is 2. So here we've got x is 2 to make the bracket 0, and when that's 0, we're left with 5, so we've got 2, 5. That is the minimum value. Okay, that's question 1 sorted. When we look at question 2, it looks a little bit more intimidating because it says 4x minus 5 minus x squared equals q minus, and then we've got this bracket, x plus p all squared. Well, to sort that out, the first thing I'm going to do is take that function and I'm going to rewrite it in order of powers. So I've got minus x squared plus 4x minus 5. And we know we're used to completing the square with just an x squared, not a minus. So I'm factorising -1 out straight away. So you'll notice the minus x squared becomes positive x squared, this plus 4x becomes minus 4x, and this minus 5 becomes plus 5. Just take that -1 out, we'll deal with it later. Now that we've got it in that form, we can just go ahead and complete the square like we did in question 1. So I've got half of the -4 is -2, so it's x minus 2 all squared, minus the 2 squared, because we square whatever we've put there and take it away, plus 5, because we've got the 5 there. That simplifies down to +1. Alright, so I've got -1 out here still, x minus 2 in brackets all squared, plus the 1. And all I'm going to do is I'm going to multiply through by that -1. So that's minus bracket x minus 2 all squared. So we've got the negative of that, and this plus here becomes a minus when we times through. And that's pretty much it. You don't need the last line. I've just rewritten it so that it looks a little bit like we saw it in the question. And there's a little bit of a trick here. It says q here, but we know we've got a negative here. So q equals -1 in this case. And the other little trick they've put plus p here. So whereas in this case it had minus p and we had -2, so p was just 2, here it's got plus p and we've got -2, so p is -2. So watch out for those little tricks, but the essentials are still the same. Half of b in the bracket, square all of it, and take away the square of whatever you've got there, plus your c. Welcome to Inequalities 101. We've got the question, find the set of values for x which, and in part A, we've got 2 marks here for a linear inequality. It says 6x minus 7 is less than 2x plus 3. But with your linear inequality, I'm just going to solve this like it was an equation. So I'm going to get my x's in one place by taking away 2x. That's 4x minus 7 is less than 3. Take my 7 across by adding 7 to both sides. That gives me 4x is less than 10. And then to get x on its own, I'll divide by 4 to give me x is less than 10 over 4, which simplifies down to x is less than 5 over 2. So x is less than 2.5, That's your linear inequality. Part B is worth 4 marks, and that gives us a quadratic inequality. So it tells us that 2x squared minus 11x plus 5 is less than 0. Okay, well, to solve this I'm going to factorise it first, get my critical values of x. If this was a horrible question, you might have to do something like formula, but my critical values is what I'm after. So I factorise it into 2x minus 1, x minus 5 is less than 0, so x is a half or 5. Now the reason I do this is because this is where winners draw sketches. If I want the inequality solved, I draw my graph going through a half and 5, and if I want the bit where it's greater than, I'm going to pick these outside bits above the x-axis, or if I want the bit where it's less than, as in this case, I'm going to pick the bit where it's below the x-axis. So I want the bit in between a half and 5, so x is greater than a half and less than 5. And that's 4 marks on your quadratic inequality. Now, very often they might throw in a part C for a mark where it says find the values of x for which both 6x minus 7 is less than 2x plus 3, that's part A, and 2x squared minus 11x plus 5 is less than 0, that's part B. Now the clue here is it's 1 mark, we don't have to do a lot of work. All I've done is draw my number line and put my answers from A in, that's part A, x is less than 2.5, and part B in, x is between a half and 5, and I'm looking for the bit where they overlap, that's this here, where x is between a half and 5 over 2. 7 marks for inequalities.
Okay, so we're going to have a quick look at discriminant questions. Now, first of all, we're going to look where the discriminant comes from. This is the discriminant here, and it's part of the quadratic formula, okay? b squared minus 4ac. Now, it's been square rooted, so there's 3 situations, okay? We're either going to square root a positive number, okay, so b squared minus 4ac is greater than 0, okay. Now what would happen there, if you square root a positive number, you get a plus and a negative answer. 2 solutions, 2 distinct solutions, they're different, or 2 real roots, okay. So that gives us a quadratic graph looking like that. Okay, if you're going to square root something equal to 0, here, b squared minus 4 equals 0, we'll get 1 repeated solution, or equal roots, and that's where the graph just skims the axes just there, okay. If we have a look at square root in a negative, we can't do that. So we have no real solutions, that's when we've got a floating graph. Okay. Now in the question, it might be like this, it'll tell you one of 3 things. It will say, we've got 2 distinct real roots, we've got equal roots, or we've got no real roots at all. And you say, well, okay, well which one are they asking for? So if they're asking for equal roots, then I use this version, when it's equal to 0, b squared minus 4ac equals 0. So what you do, you just use a is 2, and b is minus k, and c is k plus 3. You plug them into that formula, and you work out what values you get. Quite often, if they're saying there's 2 distinct roots, you end up with inequalities to solve a quadratic. And just remember, winners draw pictures. Okay then, so we've got a simultaneous equation question here. Now this one's worth 6 marks. And you're not given any like part 1, part 2, it just says solve them. So it's probably going to be nice numbers. Not guaranteed, but probably. Okay, so the first thing to do is to rearrange this one of them to get y equals or x equals. Now I'm going to go for y equals because it was easy to substitute into the next one. So I rearrange this to get y equals 3 minus x. And I've put that in place of y, and I've done that there. There it is. Right, make that look like a quadratic. Equals 0, okay? I can factorise, I get my 2 solutions for x. Do not forget to sub back in and get the y values. There we go. And look, they were nice numbers. Some of them might be fractions, but there was no surds or anything. Okay. This is a slightly harder question. Okay. Now in this question, we've got to get to this quadratic. It says eliminate y to get there. Alright, cool. So we make y equals, and I've done this over here in part A. So I make y equals 8 minus 2x. I've substituted that back in, and I got the right quadratic b. Now if you couldn't do that, you can still solve the simultaneous equation. Now this one's a bit harder, it's 7 marks, and look, they say they want the answers in the form a plus b root 17. Okay, so I know I'm probably not going to be able to factorise it, I have to use the quadratic formula. Okay, so this is what I did. I used the quadratic formula on this, Be careful with negatives. And I got this horrible thing out here, x of minus 4 plus root 17, x of minus 4 minus root 17. But that's in the right form. Now when I put that back into y, so I use this bit here, put x in to get y, I ended up with this. I'd probably do some more work in the exam. Right, okay, so we're going to have a look at some of the formulas used in coordinate geometry questions. So if you've got two random points, and I've put general points on them, x1, y1 and x2, y2, there's some formulas you definitely need to remember. First of all, midpoint, which is like the average of the x coordinates, the average of the y coordinates, nice and easy. We've got the gradient, which is changing y over changing x, okay? And also you've got the distance, which is like the difference in x squared, is the difference in y squared, and that's a bit square root with, so obviously that's a bit of Pythagoras. So you definitely need to know those formulas, okay? Right, now you might get a question later on where you've got a curve and you might be asked about tangents or normals. So that's what they look like. So a tangent to a curve is just cutting it at one point, and the normal's at a right angle to that tangent, okay? And at this point you'll be usually using the formulas for the equation of a line. So y equals mx plus c. Now you need the gradient, which you can use from this formula here, or you can use differentiation, okay? So be aware, if you've got a question, you can differentiate it, find the gradient at the point that you're after, and that'll find your gradient. Now you might want to find the intercept, and you do that by plugging a point in. Now be careful in the exam, sometimes they ask it for in a different form, so just make sure you read the question. Okay, some teachers have used this form to find the equation of a line when you've got the gradient and a point. So if you use that, use it again. Okay. One thing that links normal and tangent is this here. So if you've got the gradient of the tangent is m, and then the gradient of the normal is the negative reciprocal, 1 over m, with a minus in front of it. Now obviously, if that fraction, you just flip the fraction round. Okay, and that's pretty much all you need to know. So make sure you've got those formulas down, make sure you know those facts, you know those formulas. Obviously, the key thing to this is if you're a winner, draw a picture.
Sketches. Differentiation 101. Okay, in this question, they want us to differentiate this for part A. It says find dy dx, that means differentiate once. So we've got to differentiate y equals 5x cubed plus 7x plus 3. Now, it's nice and simple. All we do is times by the power, and then take 1 away from the power. So, I've got 5 times 3 gives me 15x squared plus 7. That's because we got 7 times 1. And obviously, any constant just disappears when you differentiate. Oh, part 2. Then for the second part, it asks us to find d2y dx squared. So it's asking us to find the second differential. We just take dy dx and we differentiate again. So what I'm going to do is times by the power and then take 1 away from the power. So I've got 2 times the 15 gives me 30x. Now just to the power of 1. We don't need to write the 1. And because 7 is a constant now, it just goes. In this question they want us to integrate the function 1 plus 3 times root x minus 1 over x squared. Now before I'm even going to attempt that for 4 marks, I'm going to change it into its power form. So I'm going to integrate 1 plus 3 times x to the power of a half minus x to the power of minus 2. Because once I've got it in power form, all I need to remember is add 1 to the power and then divide by the new power. So 1 will become x plus 3x, half plus 1 is 3 over 2, 1.5, divide by the new power. Be careful when you're sorting that out. Then I'm going to take away x, minus 2 add 1 is minus 1, so I'm going to divide by the new power, minus 1. Now when I tidy all that up, it's going to be x plus 2x to the power of 3 over 2 plus x to the minus 1. But I haven't forgotten to add c. I must always add c. I would never ever forget to add c. Because we need to add c. Are we done? Oh wait. What if they told me a point on the line? So here it says, given this function and that the point 420 lies on the curve, what do they want me to do? They want me to find C. So all I need to do is plug those numbers in. I make sure I replace y with 20, because y equals 20, and I replace all my x's with 4, because x equals 4. And you'll notice before I sub those numbers in, I changed it back from power form. It is so much easier to sub into a root than to try and sort out a fractional power. So make sure you turn it back into root and fraction form and then sub in your values. Once you sort all that out, you just find out that C is minus a quarter. So I've got my full function replacing C with minus a quarter. 5 marks or more on your exam. Boom.
Add C.
So recurrence relations. This shows you how we can build a sequence from the term before. So this means to find the next term in the sequence, we just do 2 times the one before it and take away 3. You will always be told what the first term is. So if we want to work out U2, read the formula. This says 2 times the term before it. Well, the one before U2 would be U1. Take away 3. Well, we know what U1 is. It's 4. So 2 times 4, take away 3. That's 8 minus 3 is 5. So now let's find U3. Well, that's just 2 times the one before it. Well, the one before that is U2. Take away 3. So we've got 2 times U2, which is 5. Take away 3. That is 7. Let's do one more. U4. Well, that's 2 lots of U3. Take away 3. Well, we know what U3 is. It's the one before it. 7. 2 lots of 7. Take away 3. That's 11. Now we can see that this has built a sequence that isn't arithmetic. It doesn't go up the same amount each time, which is what recurrence relationships are useful for. Right, arithmetic series. Main things to remember. A stands for the first term. D is the difference. And N is the term number, or sometimes number of terms. So, what you might be asked to do is you might be asked to prove that this is the sum of the first N terms. And this is what this notation means, Sn. So they will give you the formula, if they ask you to prove it, that's n over 2 times 2a plus n minus 1d. So the first thing to do is write out what the sum of the first n terms would look like. Well, this one is the first term, just a. The second term is a plus 1 lot of the difference. The third term would be a, or the first term plus 2 lots of the difference, and so on. And the nth term, which you might want to remember this for other questions as well, is the first term plus n minus 1 lots of the difference, because you have to just jump n minus 1 times to get from the first to the nth term. Then the trick is to write this all out backwards. Okay, so it's the same sum but written out backwards. And you write it out underneath, because then what we're going to do is add the 2 lines together. So when we add those together, we get 2a plus n minus 1d. When we add these ones together, the second terms, we get 2a plus, we put these together, another lot of n minus 1d. And that will always be the case. So if we've added these lines together, we've got 2 lots of Sn equals always 2a plus n minus 1d lots of times. But how many times? Well, if there are n terms, we get this n times. So let's just say it's n lots of that, and then divide by 2. And that gets us what we want. Right, so how do you use this in an actual question? Well, if they ask you to find the sum of this, write down a, 3, write down d, 2, n is 25, stick it in the formula. Okay, easy. What about if they don't tell you how many terms though, and they ask you to find the sum of this? Well, this is where you can use a trick. We could work out what this is, because we know what a is, it's 4, d is 3, so we could do a plus n minus 1d to work out what that is, and therefore work out what n is. But there's an alternative formula we can use instead, that you must remember this one, you're not given this. Sn is equal to n over 2 times the first plus the last. So in this one, we could just put those in and get the answer. Okay. One last thing. Remember, sigma, capital sigma, means sum of.